All right, so I quickly want to go over these rolling the dice problems. I think that these are pretty easy. I think maybe that you might have been confusing because they were kind of thrown in there randomly. But if you understand that you can just find a sample space when you have two events that are related together, then it shouldn't be too difficult. Okay, so in these scenarios, we're rolling a fair die with numbers 1 through 6. So we're doing it twice, and then what we're doing is we're adding those two rolls together. Okay, so the sum of two rolls, you can think we could also just roll two die at the same time, and we'd be adding those two die together. Okay, so if we're doing that, we have to think. There's only so many numbers that could come up. When you're adding two numbers, 1 through 6 together, there's only so many things that could come up. And if we could figure out that whole sample space, then we can find the probability of any one or multiple of those numbers coming up. And that's what we're going to do. So to first come up with the sample space, we have to think, okay, in the first event, or that first die, we could roll 1, 2, 3, 4, 5, or 6. And same thing for the second die. We could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay? So if I'm trying to find all of the numbers that these two die could add up to, I just have to fill in this whole space. So there's 6 times 6, there's 36 possible things that could come up. Let's see what they are. Well, 1 and 1 would be 2. 1 plus 2 would be 3. 1 plus 3 would be 4. 1 plus 4 would be 5, 6, 7. 2 plus 1 would be 3. 2 plus 2 is 4. 2 plus 3, 5, 6, 7, 8. 3 plus 1 is 4. 3 plus 2 is 5, 6, 7, 8, 9. 4 plus 1 is 5. 4 plus 2 is 6, 7, 8, 9, 10. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3, 8, 9. 5 plus 5, 10. 5 plus 6, 11. 6 plus 1, 7, 8, 9, 10, 11, 12. Okay? So if we're looking at this sample space, the number that's going to show up the most if we're rolling two die is 7. Because 7, there's 1, 2, 3, 4, 5, 6 ways that a 7 could come up. Compared to the 12, where the only way that 12 is going to come up is if we roll a 6 both times. That's very unlikely compared to the 7. And the reason for that is we can roll a 5 and a 2. We can roll a 4 and a 3, a 3 and a 4, a 2 and a 5, 6 and a 1, 1 and a 6. So there's multiple ways that we could get to the 7, not multiple ways we could get to the 12. Okay? Now, once we have the sample space, finding these probabilities is really easy. Because remember, probability of an event is equal to the number of desired outcomes divided by the total number of outcomes. So for event A, it says that the sum is greater than 5. So we need to figure out how many of these numbers in this whole 36 are greater than 5. Well, we can think 6 is greater than 5. 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 out of the total 36 are greater than 5. So that would be the probability. And then I would just have to round to 2 decimal places. So in my calculator, 26 out of 36 would be 0.722. So this would be 0.72. Okay? Now you have to think, for this second event, the sample space is going to be the exact same. It's not going to be any different because, again, we're just rolling two die. The only thing that's going to be different is that we're circling different outcomes because there's going to be different things that are happening based on what we want. So in this one here, for event B, it's saying that we're trying to find the probability that the sum here is both not divisible by 3 and not divisible by 5. So it has to satisfy both of these conditions. It has to both be not divisible by 3 and at the same time cannot be divisible by 5. So let's start by just circling all of the ones that are not divisible by 3. So 2 is not divisible by 3. Actually, let me change my color real quick. So 2 is not divisible by 3. Well, 3 divided by 3 is 1, so that is divisible. 4 is not divisible by 3. 5 is not divisible by 3. 6 is divisible by 3. 7 is not. 8 is not. 9 is. 10 is not. 11 is not. And 12 is. Okay, so right now we just circled all the ones that are divisible by 3. But remember, the sum has to be both not divisible by 3 and not divisible by 5. So all of the ones on here that we circled that are divisible by 5, we have to uncircle because, remember, it has to satisfy both of these. So remember, 10, that's divisible by 5, so we can't include that anymore. Sorry, that's got to go away. And the other one that's divisible by 5 is 5. So we got to take away all of these 5s. Okay, so now we're left over with all of the numbers that are not divisible by 3, and they're also not divisible by 5. So the reason that 3 is not in there is because 3 is divisible by 3. The reason that 5 is not in there is because 5 is divisible by 5. 6 is divisible by 3. 9 is divisible by 3. 10 is divisible by 5. 12 is divisible by 3. So we're left with just 2, 4, 7, 8, and 11. Now, that is only, 1, 2, 3, 4. That's 5 different numbers, but some of those numbers can show up multiple times. So if we're finding the probability, again, it's desired divided by total. There's 36 total possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 out of the 36 are not divisible by 5 and not divisible by 3. Okay, so we'll go to a calculator. Trusty calculator on this one. 17 divided by 36 this time. 17 divided by 36 is 0.47. 0.47. Okay, so hopefully that helped you understand these. I think that once you kind of see this and you look at the sample space, these are a lot easier than some of the other problems that we've done.